Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we're going to look at a few questions that I select from your tutorial book, specifically for past year questions, topic 2, equations, inequalities, and absolute values. Okay, so I do hope that all of you holding your tutorial book with you right now. And before that, please, if you don't mind, that you please click the subscribe, like, and share button my channel as a sign of support to for this channel. And I do hope that inspired me to come up with more videos that can help you in your studies here. Okay, so let's continue without wasting so much time. Okay, for this video, I'm going to concentrate on the question of inequalities. So, these all the questions that I have chose. Might be for 28, I ignored the question of 28a. So you may try the question by yourself. Okay, solve the question by yourself. I'm going to concentrate on the question of inequalities. Number 10, 15ab, 28b, and 31. Okay, class. I'm sorry if when I explaining all this, suddenly it stopped. Might be just now I make a recording and it stopped. A minute of 40. I have no idea because I subscribed this for screencast for 3 years, but it seems that it looked back to normal users with only 40 minutes 30 minutes limit for every single videos. Okay, it's a small matter. Let's continue. Okay, so first one here now, 1 divided by 2x minus 1 less than 1 divided by x plus 2. Okay, this is inequalities, not equation. If that's so, we are not allowed to come up with a process of cross multiplication. What we are going to do for this question here now is we are going to bring this to the left side to join up this one here, 1 divided by 2x minus 1 and minus 1 over x plus 2 less than 0. Okay, and the reason I may give a space here and also here. Okay, look at every single fraction that we have, 1 over 2x minus 1 and 1 over x plus 2. Both of these are fraction. By the way, both of these, okay, the denominator are not equal. So before we can simplify this, join up this into one fraction, we must make sure that the fraction the denominator are equal. In that case, we are going to come up with this process of 2x minus 1 multiplied with x plus 2 here and also here. Same goes to this one here. So x plus 2 we have here now. Okay, we got x plus 2 here. So we need another of 2x minus 1. Then 2x minus 1 and 2x minus 1. Okay, now okay, I rewrite this x plus 2 divided by 2x minus 1 and x plus 2 and minus 2x minus 1 divided by x plus 2, this one here, and 2x minus 1 less than 0. What can you see here now? Okay, refer to this denominator and this denominator, this fraction. What can you see here now? Yes, the denominator are equal now, meaning we can simply combine these two into one fraction of x plus 2, negative times 2x minus 2x, and negative times negative become positive 1 divided by 2x minus 1 and x plus 2 less than 0. So x minus 2x, negative x, 2 plus 1 equal to 3 divided by 2x minus 1 and x plus 2 less than 0. So class, if you realize that just now this is a question, and now we got 3 different linear factors. The first is negative x plus 3. Next is 2x minus 1 and x plus 2 less than 0. So this we call factor number 1, 2, 3. Let's put in line, same line together, negative x plus 3. So we assume all these 3. Assume first all these 3 are greater than 0. 2x minus 1 greater than 0 and x plus 2 greater than 0. Okay, negative x greater than negative 3. Then this one here, x greater than negative 1 here become positive 1 divided by 2, 1 over 2, and x greater than negative 2. For this one here, we divide by negative 1 left and right. So then x less than 3, x greater than 1 over 2, and x greater than negative 2. Okay. Then, negative 2, half, and 3. So, x less than 3. Okay, sorry. Okay, I use a different colors and at a different level, not the same level. This one and this one here, just to show you the recall. We are going to use the sign of positive and negative. Okay, for x greater than half. Okay, and another one here, x greater than 3. X greater than negative 2. Okay. So then the rest of it, okay, for this one here, we make this kind of line, and also here and here. So we got 4 different section orange. Okay, from negative infinity until negative 2, negative 2 until half, half until 3, and 3 to positive infinity. Okay, so then now we got positive, positive, and negative here. Positive, positive, and positive. Positive, negative, positive, negative, negative, positive. Okay, so it's either multiplied or divide. Multiplied or divide with a positive and negative. We know that positive value multiplied with negative value equal to negative, and negative divided by negative equal to positive. I do hope that all of you remember that. Okay, so now negative multiplied by negative, positive divided by positive, positive. Positive divided by negative, negative multiplied by positive, negative, positive, and negative. So the final answer for this question, for this solution here, okay, refer to this step or this line, and the whole of this, or this one here. Wait. I think that the best one, we can refer to this because all these three factors form this we call number line. Okay, this one, negative x plus 3 divided by 2x minus 1 multiplied by x plus 2, as you see the screen here now, is less than 0. So numbers that less than 0? Yes, negative. This one here and here. So the final solution set. Okay, so then is from here negative 2 until half union 3 to positive infinity, which is less than 0. Negative. There you go. Okay, so then this one here now, 3x divided by 5 minus x greater than or equal to 6. So we cannot simply, as I said, that this 5 minus x is not always positive. So the best thing we can do here now is we're going to bring this 6 to the left side. Minus 6. So I straightly come up with we call to equalize, change this in fraction and equalize with the denominator of this. So then come up with 5 minus x divided by 5 minus x greater than or equal to 0. Okay, so then we got 3x negative 6 times 5 minus 30, negative become positive, 6 times x, 6x divided by 5 minus x, okay, 5 minus x greater than or equal to 0. 3x plus 6x, 9x minus 30 divided by 5 minus x greater than or equal to 0. So class, what will be next? Okay, for this one, if I recall, factorize with 3, then we get 3x, 3 times 3 equal to 9 minus 10 divided by 5 minus x greater than equal to 0. It's okay. It's either you refer to this 9x minus 30 or 3 times 3x minus 10. It's all up to you then. So let 3x minus 10 greater than or equal to 0 assume. Let means that we assume these two factors. Just assume it. No matter whether the sign of this is less than or greater than. It's no, we call nothing to do with this one here. So assume this two is positive. By the way, the numerator can be equal to 0, but not for denominator where 5 minus x is only greater than 0. Greater than 0 only. Okay, so then x greater than or equal to negative will become positive 10 over 3, and this one here negative x greater than negative 5, then x less than 5. Okay. Okay, I need a space for this question of A. Okay. Now, for this one, x greater than equal to 10 over 3 and x less than 5. Do you find any sign of and or O here? No. So it means that we are going to come up with number line 10 over 3. 10 over 3 is 3.33 something, so it's less than 5. 10 over 3 and 5. Okay. Greater than or equal, and this one is less than. So we are not we are not going to finalize this answer, okay, this solution with intersection, because there is no term of and here. So we can only come up with playing with a sign of positive and negative, with negative, positive, positive and positive, positive and negative. Of course, divide between these two, positive divided by negative, negative, positive and negative. So the final solution set, which range that we're going to choose then? Refer to this. And this one is greater than or equal to 0. Greater than is always positive value, right? Then this one here. So the final solution set, final answer, which is from 10 over 3 until 5. There you go. Okay, because this is a video session, so if I erase this to come up with the solution of this one, you may stop, rewind, and forward, pause, and whatsoever, as long as you can see you can see all the solution, we call explanation of all this solution. Okay, I need a space for this one here, so I'm gonna erase this. Okay, the final answer is 10 over 3 and 5. Okay, I rewrite here, the final answer is 10 over 3 until 5. The solution is where I wrote it just now. Okay. Now, for this one, okay, for this, when we have absolute values, both left and right, we can simply just come out with cross multiplication of modulus of x is also equal to square root of x squared. Okay, so if we square this one here, so it eliminate between this and this square root sign, then only x squared left. So then modulus of 3x minus 5 sorry, less than modulus of x plus 1 square left and right. Okay, so come up with 3x minus 5 square less than x plus 1 square. So expand on this, 3x times 3x, 9x squared. 3 times negative 5, negative 15, double negative 30x, negative 5 times negative 5 plus 25 less than x times x, x squared plus 2x plus 1. 9x squared minus x squared is x squared. Negative 30 minus 2 minus 32x. 25 minus 1 plus 24 less than 0. Okay, so 8, 32, and 24, which I think that we can factorize or divide by 8, right? Then we get x squared, 8 times 4, and then plus 3 less than 0. 8, 4 times 8 is 32, and 8 times 3 is 24. Okay, that's it. So then factorize this, and then we get x and also x, 3. With 3 and 1, there's only choice that we have. Multiplication multiplied of between 1 and 3 equal to 3. By the way, we get negative 4 minus and minus, x times x, x squared, negative 3x and negative 1x, negative 3 minus 1, negative 4x. And negative 1 times negative 3 equal to positive 3. So, again, let x minus 1 greater than 0 and x minus 3 greater than 0. So, we assume both of these factors greater than 0. Then x greater than 1, x greater than 3. So, 1 and 3. So, we got positive, positive, negative, positive, negative, and negative. We got positive, negative, and positive. Okay, so the final solution set refer to this line where these two factors multiplication between these two factors is less than 0, and numbers at less than 0, negative value. Yes, that's it. So the final solution, which is from 1 until 3. Okay, for this one, I mentioned to you all just now, I'm focusing on the question of inequalities. So equation of log, index, and surd. I'm sorry. I have no idea what's wrong with this. Okay. For this one here, modulus of 2x minus 1 divided by x plus 3 less than or equal to 1. Okay. So when it comes to this, more absolute values of function less than or equal. So in this case, we can simply just come up with 2x minus 1 and x plus 3 less than equal to 1 and greater than or equal to negative 1. Okay. Okay, class. I have double checked for these questions. Okay. First option number 1. Option number 1, we can form from this question, from the question here into this form, and then we come out with 2x minus 1 divided by x plus 3 for this greater than or equal to negative 1, and 2x minus 1 divided by x plus 3 less than 1. Okay, this is option number 1. Okay, so solve one part, another part, you get the solution case 2, solution case 1, and combine them all together to get another one final solution. Okay, option number 2, which I think that I explained to you this one here. The reason that I explained this one, and I just leave it to all of you to try on this. Okay, try by yourself. Once you get the first solution here and the second solution here, then combine together to get one solution because you have the term of n here. Okay, I choose we call option number 2. 2x minus 1 divided by x plus 3, which is less than or equal to 1. Please refer to your notes, or I did mention to all of you, this is an equation, a question of inequalities. We cannot simply cross multiply, bring this denominator to the other side and multiply with 1. Am I right? Because denominator x plus 3 is not always positive at all time. But then for this question, we have sign of absolute values. Absolute values means that whatever value that x in this function and the result is whether positive or negative, it will always be positive at all time. So, absolute values of x plus 3 is always positive, then I may straightly bring this to the other side. Okay, again, if if this is a question 2x minus 1 divided by x plus 3 without the sign of absolute values, okay, so if I bring this multiply with x plus 3, we are not allowed to do so because x plus 3, if x is negative 4, negative 4 plus 3 equal to negative 1, then the denominator is negative. So it will bad effect to the whole inequalities question here. But then for this question here now, we got absolute values. Absolute values is always positive for all values of x. So we may bring this here, okay, x plus 3 here. And we allowed to do so because x plus 3 is always positive for all values of x. Okay. Now, if that's so, then cross multiply here, we got 2x minus 1 less than equal to x plus 3. Then we squared left and right. Same thing goes to the previous question here. Okay, inequalities, but then absolute values left and right. So we squared both left and right. Okay, same goes to this question here now. Then you come up with 2x minus 1 squared less than equal to x plus 3 squared. So expand this, 2x times 2x, 4x squared, 2x times negative 1, negative 2x, another negative 4x plus 1 less than equal to x squared plus 6x plus 9. 4x squared minus x squared, 3x squared. Negative 4, wait a minute. 3x minus 5, x plus 1. Okay, which I think that is quite almost the same as this one here. Nope. Okay, never mind, maybe a mistake then. 4x squared minus x squared, bring this x squared to the left side, become negative. So 4x squared minus x squared, 3x squared, negative 4, minus 6, negative, then x. And then 1 minus 9 minus 8 less than or equal to 0. Wait a minute, 3x squared minus 10x plus minus 8. Where did I find that this equation recall? Okay, maybe because I recall I discussed this question with my with my students. It looks familiar here. Okay, never mind. Then this one here. So then 3x and x. 3x multiplied with x, 3x squared. So now we get 8. 8 is a combination of 1 multiplied with 8, 2 times 4. 3, no, 4, 4 times 2. Okay. So now, and the difference here is negative 10. So we need to consider this 3 here. Okay. Or 3 times 8. 3 times 8 equal to 24. And then minus 1, 24 minus 1, 23. Or 3 times 1 equal to 3. And then with 8, negative 11. No. Okay, this is not it. So, if I put it here, 4 and 2. 3x times x, 3x squared, 3 times 4, negative 4. 3 times negative 4, negative 12x. And then positive 2 times x plus 2x. So, negative 12 plus 2 equal to negative 10. There you go. Okay. So then now, for this one, we got 3x plus 2. Okay, sorry then. Okay, 3x plus 2, we assume for this one here, let this one greater than equal to 0. And x minus 4 greater than equal to 0. Multiplication. Okay. So then x greater than equal to negative 2 over 3 and x greater than equal to 4. Negative 2 over 3 and 4 greater than or equal and greater than or equal. Okay, so we got positive, positive, negative, positive, negative, and negative. So multiplication between these two factors, substitute value of x, and you get negative times negative, positive, negative, and positive. So the range that we want, refer to this, okay, this line. For multiplication between these two factors is less than or equal to 0. Less than, of course, it is negative here. So the final answer, okay, it is from negative 2 over 3 until 4. There you go. Okay, now. Okay, so for this one here now, we call absolute values of this greater than 2. Okay. Option number 1. Okay, so for question 31, I'm going to use the definition of what we call the absolute values of this. For absolute values of x minus 1 divided by x plus 3 greater than 2. Okay, so just now we used the we call cross multiply and also squared left and right. So let's use the other method here. And for this one, for greater than means that it is something we call x minus 1 divided by x plus 3. Okay, with 2 here, just imagine that there is a negative 2 and 2. One on the left side, on the left side, and the other one on the other side. So just imagine that this x minus 1 divided by x plus 3 here, and also x minus 1 divided by x plus 3 here. So x minus 1 divided by x plus 3 less than. Okay, all this now, these values is less than negative 2. Okay, less than negative 2, or x minus 1 divided by x plus 3 greater than 2. Okay, so from these questions, from these inequalities, I separate into two parts, which is case number 1 and case number 2. So now, negative 2 bring to the side become positive, so then x minus 1 divided by x plus 3 plus 2 less than 0, or this one here, x minus 1 divided by x plus 3, bring these two to the left side, become negative minus 2 greater than 0. So again, the reason I give a space here, so that I'm going to turn it into a denominator from these two to a fraction of this with a denominator of x plus 3 and also x plus 3 here. And what about this one here now? Yes, the same here, goes to x plus 3 multiply with x plus 3. Okay, now x minus 1 negative positive 2 times x plus 2x, 2 times 3 equal to 6 divided by x plus 3, and positive addition here with x plus 3, we call the denominator are equal now, so we come out with x plus 3 less than 0. Okay, x plus 2x, 3x, 6 minus 1 plus 5 divided by 5 divided by x plus 3 less than 0. Okay, and this one here now, x minus 1 negative 2 times x minus 2x negative 2 times 3 minus 6 divided by x plus 3 greater than 0. And then x minus 2x, negative 1 minus 6, negative 7 divided by x plus 3 greater than 0. Okay, so we divide into two parts here. We are going to find a solution set for this half of this, case number 1, and another one here, case number 2. Assume or let then 3x plus 5 greater than 0 and x plus 3 greater than 0. So then x greater than negative 5 over 3 and x greater than negative 3. Okay. So then this one here, negative 3 and negative 5 over 3. 5 over 3 remains 2 something, 1 something. Okay. So then both are greater than. Okay. So in this line, in this section, you find that there is no term of and or, not including this part only. Okay, so then we are playing with positive, negative, positive, and negative and negative. So positive, negative, positive. So refer to this line, which everything here is less than 0. Yes, negative. So the first solution set for case number 1 here is from negative 3 until negative 5 over 3. Okay, what about this one here now? Let negative x minus 7 greater than 0, x plus 3 greater than 0, then negative x greater than 7, then x less than negative 7, and x greater than negative 3. Negative 7 and negative 3. Both are, okay, one is less than and the other one is greater than. So then we got positive, negative, 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 positive. So negative, positive, negative. So then refer to this line here now, which everything here is greater than, and greater than is always positive, right? So this is a solution set A1, which is from -7 until -3. Now, this is a solution set for case number 1, and this is a solution set for case number 2. And between these two, 1 and 2 here, we are going to find the final solution set using this term of all. All means all of them, okay? So just imagine that if I supposedly to doing this final solution set down here, but then because it's almost the end. Okay, now just imagine that if I bring this and this in one number line. Okay, solution number 1 is between -3 until -5/3. So -3 until -5/3 here. And then solution number 2 is from -7 until -3. -7 until -3. So refer to this now is a term of or, not and. Meaning, we are taking all the solution set 1 and set case number 2, all of this, so the final solution set, which is -7 until -3, union -3 until -5/3. There you go. Okay, that's all for today. Thank you very much. Until we meet again in the next video. And I do hope that all of you are satisfied. And please do continue the rest of the question by yourself. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.